Hello and welcome to a video on the restoration of this Sony TA-4650 VFET amplifier. I bought this thing off of eBay to have a project to do during the quarantine, and it works perfectly well, which is actually pretty rare for these things. And as you can see, it's in very good cosmetic condition too. But these units are known to have a few diodes and some design flaws, which mean that eventually, after running them for long enough, they tend to kill the output transistors. So I'm going to do a full restoration of this, including replacing those diodes, doing some mods to the power supply, replacing the capacitors, the trimmers, some other stuff, and cleaning all the pots and controls, etc. The standard kind of restoration things that people do with old amplifiers. And as you can see, this TA-4650 is actually an integrated amplifier, so it has both a preamp, a phono stage, and the amplifier itself all in one unit. And what makes these things really special is that they use VFETs. VFETs are a type of field effect transistor that was manufactured only in the 70s and early 80s. They haven't been made since, so they're basically impossible to replace if they're bad. And that's why I was very excited that this unit works, because I will not have to replace the VFETs, which are really difficult to source. The only way to get them is from a parts unit, because like I said, they haven't been made at all. Basically, their only application is in audio equipment, and it's just not economical for people to run a whole production line to make VFETs. So yeah, the only VFETs in existence are the ones in amplifiers like this. And this unit uses VFETs both as its output transistors, and there are also two VFETs in the phono amp. So yeah, this video is going to cover a restoration of this unit, and let's take a look at the inside. Alright, so now I've got the TA-4650 opened up. It's pretty easy to remove the cover, just 4 screws, 2 on each side. And so yeah, let's take a look at what we've got here. So this is the power transformer. This is the power supply board. Here is the amplifier board. And then a little bit hard to see, let me move the camera. This right here is the phono board. And these are the 2 phono VFETs right here, the flying saucer metal transistors there. And then this is the preamp board, as well as all these boards which host the controls on the front panel. And then the output transistors, the output VFETs, are on the opposite side, on the bottom side, mounted to this heatsink. As I suspected, this unit does not appear to have had any of the modifications I'm going to do done to it previously. Even though the screws on the side were all at different tightnesses and looked like they had been opened before, so I think somebody's been in here. Evidently, they didn't get the memo about replacing all the components that need to be replaced, because I can tell these are still the original problematic diodes. Maybe I can zoom in a bit. Let's see. Yeah, so these diodes right here are the problematic diodes, which tend to kill the outputs, and the other one on this side, you can't see that. But anyways, yeah, those are the problematic diodes which need to be replaced. There are 3 of them. And then also there needs to be a diode mod done to the power supply, which has not been done. And the capacitors appear to be original capacitors as well. So whoever opened this didn't really do significant work on it, although I do think that some of the soldering in here is non-original, including some of these fuses, which appear to have big globs. You can see on the left right here. That soldering is really, really messy. It doesn't appear to be original. It looks like someone who didn't really know what they were doing reattached those. And so maybe the fuses blew at one point and they were replaced, which makes it even more surprising that this thing still works, but it does. So yeah. The next order of business is to make a parts list. And theoretically, you could do the entire parts list using the service manual, because it lists all the parts, it has a full schematic. But in general, with these units, oftentimes on the fly revisions were made during production as issues were discovered. And so oftentimes what's actually in the unit will be different than the schematic on the service manual. So it's generally safer to just go through and actually count every single capacitor and every single transistor and whatnot that's going to be replaced. All right, so I chose not to show me counting up all the capacitors because that's very boring. But I did spend a few hours going through, taking stock of everything, and also reading some forum threads, looking at the schematic, and just kind of generally planning things out. And I've got a provisional parts list here. Actually, it's pretty much finalized. It has all the capacitors and some diodes and the new relay for the speaker protection board and some new trimmers. I'm still undecided on the small signal transistors, the low power transistors. Those may or may not be replaced, probably not at this rate. Some of them are actually pretty hard to replace, or the replacements are kind of obscure. So I'll probably just leave those in. And they all appear to be functional anyways. The biggest challenge was the power supply filter caps. As you can see here, let me just adjust this. The power supply board actually screws directly into the filter caps, which means that they're kind of a structural element. So the replacement filter caps don't have the same lead spacing because the originals have 14 millimeter lead spacing and no caps with 14 millimeter lead spacing exist anymore. Also, the originals are 40 millimeters in diameter and there are no 40 millimeter diameter caps of this capacitance value made anymore. So the best solution I could find was to use 13 millimeter lead spacing, which should be close enough that it'll screw in properly, and to just use a smaller diameter and use some sort of padding to mount that. So anyways, hopefully that works well, and I'm going to put the order into Mouser, and those parts will be here shortly. All right, so the parts are still a few days out, but in anticipation, I'm going to do some disassembly to make sure that all the PCBs are accessible so that once everything gets here, we'll be able to jump right into the recap and all the modifications. So the first order of business is to remove this amplifier board. All right, and it should lift out. Let's place that off to the side. All right, next we're going to take off the faceplate, starting with these two inner screws on the top. Next, we want to remove all these knobs on the front. And then lastly, there are these two screws on the bottom of the faceplate that need to be removed. All right, and with all that done, you can just rotate the unit back slightly, and the faceplate should come right off. That reveals this inner structural faceplate, which actually holds the PCBs on. So to access the bottom of them, we're going to need to remove this too, starting with these two screws at the top. And then these two on the bottom of the unit as well. And with that done, the structural part of the faceplate can be simply removed from the bottom. And now we have access to all of these boards. All right, so all the parts have arrived, and we're going to start with the amp board. In order to dismount this thing, we need to remove this back plate and also remove the output transistors since they're connected to the board over here. So yep, just 8 screws securing these in, and we'll get started with that. All right, so now that those are unscrewed, we just lift them off. Try to pull out as straight as possible so the pins don't get bent. And sometimes wiggling them helps. And then we have the mica washer. It's good to save these, although we're not going to need them since I bought an insulating thermal pad to use instead. And I'm going to clean the entire heatsink later as well as the outputs, but for now let's just focus on getting the amp board dismounted. So next, on the back we have screws here and here. And with that, the amp board should be completely dismounted, so we can remove this back plate here. And then the whole thing lifts out. Actually, we have one more transistor on there. Let's get that removed. It's mated to the heatsink. All right, and there's our amp board. So now we have access to the back and we can begin to do our diode mods and our recap. All right, so the most important aspect of this project is to replace the double diodes. They're known to fail, the ones used in this unit, and if they fail shorted, it'll basically blow the outputs. So the double diodes are these little black things you can see right here. They look like little black droplets with leads attached. There's one here. Let's see if that focuses better. There's one here, and then there are two mated thermally using thermal compound to these transistors, one there and one there. So the proper way to replace these is to basically just construct a double diode using discrete 1N4148s, which are a very, very common signal diode. You can see here. They're dirt cheap. They can be had from Mauser and whatever. So basically you just construct it by taking the two diodes like so, and then just twisting the leads such that they make contact here. And then you can just solder that connection together and you'll have a replacement for the double diodes. All right, so let's just make two more of those. And in general, it's best to get the leads twisted as tightly as possible. I actually had to redo my first one because I didn't do a very good job of it. But now that we've got those, we're going to just solder the top together and then cut off the excess on the top. All right, looks pretty good. And the next step, of course, is going to be cutting the excess part of the leads because we don't want all this hanging off. So just right where the solder joint ends, you can cut that off. And there we have our replacement double diodes. All right, so now we need to desolder the old double diodes and replace them with the new ones. All right, so we got those all soldered in. Took a bit longer than expected due to some shenanigans with the thermal compound on the transistor getting onto the legs of the diode while I was inserting it. And some of those old thermal compounds are pretty nasty, so I didn't really want to solder that. But anyways, we've got them in now. 1, 2, and 3 right there. And the next step is, so these two need to be thermally mated to this transistor. So the way I'm going to do that is using thermal compound and another piece of heat shrink to hold these together. All right, so I'm going to be using Thermal Grizzly. It's just non-conductive thermal paste, normally used for CPUs, but I have a big tube of it here. So, yep, the goal is to just get it onto this transistor and the diode, and then to be able to kind of squeeze them together. All right, looks pretty good. And I think it's going to be a good idea to heat shrink this together because the thermal paste is pretty runny, and I think that it's going to be helpful if the whole thing is held together in some way. So we've got our heat shrink here. Just going to try to cut it to a roughly appropriate size. And going to want to slide this onto here. All right, that looks good. I'm not sure it'll shrink enough. Worst case scenario, we can always cut it off and redo the whole thing, but thought I'd give it a try, so. We actually got a bit too much shrinkage in the vertical direction, but it does look like it's holding on pretty well there. So I think I'm going to just leave it and yeah, just cut the top. All right, so I did end up redoing the heat shrink on this other double diode. The old one I did was so bad that it wasn't really making good contact. But anyways, now that that's done with, I'm going to do the recap on this board and do the trimmer replacement. The trimmers are right there, and then all the electrolytic capacitors are going to be replaced. This board has the most capacitors of any board on the amp, so it's definitely going to take a fair amount of time. And I'm going to be showing it as a longish time lapse with some music in the background. The music is by my friend Nicholas. Thanks, Nick, for letting me use it. And if you like it, you should definitely check out his SoundCloud. The link will be in the description below. All right, so our amplifier board recap is complete, and the last thing left to do on this board is to replace the bias trimmers, one right here and one right here. And the bias trimmers are very important on this amplifier because JFETs, which are output transistors, are depletion mode devices. So basically what that means is that if they lose bias, they become essentially shorted and they'll quickly overheat. So the functioning of the bias trimmers is very important, which is why I want to just put new ones in just in case these ones are close to failure. But before we do that, it would be nice to get a resistance reading on the bias trimmers because this amp was working when I bought it, and it's nice to have kind of a baseline of roughly what your new trimmer should be set to. So yeah, let me grab the multimeter and we'll do that real quick. All right, so we're going to probe these. All right, so about 0.7 and 0.5. Now we can just do the replacement. All right, so now we've got both of our new trimmers installed. That's pretty good. The wiper lead had to be bent forward a bit. It's usually the case with new trimmers. They almost never fit the same footprint as the old one, but they're quite secure in there. So yeah, looks good. So I think the next thing we're going to tackle is this board right here. It's the board with all the buttons on it, part of the preamp section. It only has 5 caps on it, so I want to just get this out of the way. And then we're going to do some of the other preamp and phono boards, and then finally get to the power supply. So anyways, let's get right into it. All right, and the next board for recap is going to be this board, the Phono Board, and it's going to be kind of a pain because it's way up high and it's kind of wobbly up here, but we'll give it our best shot. Okay, next up is the volume pot board. There's only 3 caps on here, but some of the pads on the back are actually inaccessible with this mounted, so we're just going to unscrew it here real quick so that I can get access to some of the pads that are under this metal piece here. And that leaves this loose so that we can get access to some of these pads down here. Okay, so that's actually going to be the end of the first video in this 2-part series on the restoration of the TA-4650. We got through recapping all the boards except for the power supply board, and also we got through the amplifier board diode mod and the heat shrinking and all that needed to be done there. The next video is going to cover the power supply recap and the power supply diode mods, as well as redoing the thermal interface for the output transistors, and then of course testing and adjustments and seeing if it works. I haven't gotten the second video fully shot yet, but I can already tell you that there's going to be somewhat of a surprise that involves components exploding in an unanticipated fashion. So not to be too clickbaity, but there you go. That's what will be going on in the second video. And also I'm working on some graphics cards, trying to put together some volt modding and extreme overclocking stuff. So keep your eyes out for that too. And thanks for watching, and hopefully the second part will be up without too much delay.